Hey, it's your old pal Lucid Stu again, and we are heading back to the Northeast Corridor. In February, I went over some hypothetical ways to improve geometry on the NEC in an effort to get Acela service up to a more modern average speed for a high-speed rail system. In that video, we saw it is possible, but there were a lot of comments about how I chose to go about that. I promised to address some concerns brought up, and here we are. First, we'll look at an interesting concept in the NEC Future Environmental Impact Statement from 2017 that didn't make the cut. We're starting in Perryville, Maryland, on the north side of the Susquehanna River. Just past Amtrak's maintenance facility, the track would diverge from the NEC main line to the north and join up with US 40. Amtrak is not as forgiving as I, and will take out at least 3 dozen structures over 16.5 miles, a fair amount around US 40. From there, the route kisses the CSX Philadelphia subdivision and Interstate 95 before blowing through a bunch of structures on its way back to the NEC main line just west of Newark, Delaware. This new right-of-way would be capable of 160 miles per hour. However, the existing main line is pretty fast and only a mile longer, so time savings would only be about 2 minutes. I estimate cost on this at $2.6 billion. That's $160 million per mile and $1.3 billion per minute saved. Is it worth it? You decide. Since I've mentioned cost, let me briefly cover my cost estimation algorithm. Number 1, is it an existing or new right-of-way? Number 2, where is this right-of-way? Is it an urban, suburban, or rural area? Number 3, how does the alignment relate to ground level? Is it at grade, aerial trench, or in a tunnel? And number 4, how do regional variations in construction and engineering costs factor in? In this video, that won't really play a part because most areas mentioned are close to the algorithm baseline. In the last video, I had an idea for a Philly bypass through New Jersey. All the Pennsylvania people were whining about not feeling special enough, so I took another look between Wilmington, Delaware, and New York City for missed opportunities. There's really nothing there worth doing from a geometry standpoint except for maybe the Philadelphia tunnel concept, so let's look at that. Starting at Chester, Pennsylvania, the route would need to cross over State Route 291, and then it would continue for a few more miles on viaduct to separate from freight on a Conrail spur line. This would eliminate about a dozen structures on the west end of Philadelphia International Airport. This is another NEC future idea. The one in the environmental impact statement goes underground, has an underground station at the airport, and 13 miles of tunnel under Philadelphia. I found it a little extravagant. For an airport connection, I went with an expansion of SEPTA's Eastwick station. NEC Regional can stop there and then grab SEPTA for a 2-mile trip to the terminals. Easy enough. You'd want this to replicate a similar current service pattern from the Philadelphia 30th Street station on the main line. Back to my approach, after taking out the houses, we can go back to ground level because there is room for extra tracks closer to the airport. This would continue for 4 miles through said Eastwick station. I would have it curve under Passyunk Avenue to potentially save some money with cut and cover, then curve again under Broad Street and the existing metro. Geometry through here is a consistent 125 miles per hour. This would continue to the Center City area. Personally, I think it would be awesome to have a station next to or under the old Reading terminal. However, I've never been to Philadelphia and don't know the best location for a new station, so if you're familiar with the area, let me know in the comments where you'd put this central Philadelphia station and why. From there, curving northeast and then emerging from the ground at a partially derelict line just northeast of the Conrail Richmond Industrial Tract. Looks like this was owned by Pennsylvania Railroad and then Penn Central, but I was unable to figure out who owns it now. It might be Amtrak. Leave a comment if you happen to know. That continues through Frankford Junction with room for 3 tracks. Frankfurt Junction is a 50 mile per hour NEC choke point that some of you wanted to get rid of. This accomplished that. While we're at it, let's take out half a dozen buildings to fix the proceeding curve. That would allow speeds of 110 miles per hour from the north to continue unabated toward the center of Philadelphia. That is 19 miles of track, which can be traversed in 13 minutes with the stop in Center City. That's about 5 minutes faster than the current route with a stop at 30th Street. How? A lot of the NEC's slower geometry in this area is around the 30th Street station. You need to slow for the stop anyway, and the current routing is only a mile longer. That 125 mile per hour geometry is somewhat wasted slowing for a central Philadelphia station. Those 5 minutes will cost you about $11 billion for a total of $580 million per mile and $2.2 billion per minute saved. Now you know why I skipped it. Next, on to New York and back to the Long Island high-speed railroad concept. There were some gripes about my routing through Long Island. To placate you, I will try a different way. But first, let's address some criticism of 4 tracks between Floral Park and Hicksville in the last video. There are 3 tracks now. I asserted adding a 4th wasn't a big deal. Visually, this is the case, but does it hold up to measurement? I'm using a fairly tight standard of 80 feet of width for the tracks and 120 feet for a station based on existing width to the west of Floral Park. There are some places where this will work, but plenty more where it won't, and the greater percentage is won't. It looks like you could do it for commuter rail in the current configuration, but high-speed rail with catenary here? It's not impossible, but on closer inspection, I'm going to agree that you'd need to demolish a lot of structures and would probably run into a lot of community opposition. However, there is another option. As with the now untenable route from Manhattan, we'll follow the NEC to Sunnyside Yards in Queens, then divert to Jamaica Station on the LIR main line. That, as the 3rd busiest train station in the country, is a stop 11 miles east of New York Penn. Jamaica also has a transit connection to JFK International. As with last time, a large portion of Long Island is 3rd rail, and we're going to want catenary in order to get to our Acela II top speed of 160 miles per hour. We've determined the LIRR main line from Floral Park to Hicksville is not a good option, so where do we go? At Floral Park, the partially abandoned Hempstead branch through Garden City branches off and then rejoins the main line at Farmingdale. This is another NEC future idea, but was also suggested in comments. The transition from the main line can handle about 60 miles per hour. The line has 3 curves before Farmingdale, and all are about 110 mile per hour capable. The NEC Future has this mostly in trench. The right-of-way is really only wide enough for 2 tracks, but there are some places that can handle 3 or 4 to facilitate passing. This 13-mile section would take about 8 minutes. Farmingdale at the eastern end has 2 tracks and no more without a major reconfiguration. East of Farmingdale, the route is straight and widens out, able to support 3 or 4 tracks depending on the area. The first viable stop east of Jamaica is Ronkonkoma, which is 17 miles east of Farmingdale and near Long Island MacArthur Airport, which is an executive airport that also has a small amount of commercial flights. East of Ronkonkoma is mostly single-tracked and diesel-electric. This makes electrification easier, and there's plenty of room for a second track. That continues another 26 miles east to Riverhead, where I like a third and final Long Island stop. There are a couple of curves between. Those can be reasonably improved to a 125 mile per hour standard. This route would be able to maintain a speed of 125 to 160 miles per hour nearly the whole length of the island east of Farmingdale, really earning the moniker Long Island High-Speed Railroad. Things around the Riverhead station would need to be reconfigured, but it's possible. East of Riverhead would be another 19 miles to Greenport. There are more curves that need to be fixed, and 8 or 9 structures are in the way. Overall damage is pretty light considering the distance we're covering. On the west end of Greenport, we'll curve north at 60 miles per hour and take out a few beach homes to make room for the undersea tunnel portal. Any thoughts about Orient Point or island hopping to Rhode Island are not realistic options due to inevitable opposition from various groups. The Greenport Tunnel would run along the seafloor for 12.5 miles and then a few more below ground to reconnect with the NEC in Old Lyme, Connecticut. Another mile of tunnel would get to Interstate 95 instead, but we'll come back to that later. Now that we've gotten to Connecticut, let's talk Turkey. This 111 miles of track from New York City to Connecticut through Long Island is going to average 107 miles per hour, including the 2 stops, for a travel time of 1 hour and 2 minutes. That would result in a New York City to Boston time of 2 hours and 30 minutes. Compare that to our Port Jefferson option in the last video, which would take 2 hours and 50 minutes without improvements in Connecticut. I also have the Greenport option as $6.8 billion cheaper at $27 billion. That is $240 million per mile and $360 million per minute saved. Still in New York, the last video mentioned a tunnel between New York Penn and Grand Central Terminal, then the possibility of using the Harlem line to get out of New York City. The question was posed, what if, instead of continuing north at the Woodlawn station to White Plains, you took the New Haven line through Mount Vernon and hooked back up with the NEC at New Rochelle? This would be about a mile shorter than current, but it wouldn't have to contend with Sunnyside Yards or the Pelham Bay movable bridge. Because of this, the Harlem line combined with the New Haven line could be 10 minutes faster, assuming congestion allows it. Another question mark is cost, because like the Long Island Railroad, you need to figure out what to do about the third rail situation. As a result, I have a range of $6 to $12 billion, so let's pick 9. For this 17.5 miles, I have an average of 65 miles per hour and a time of 16 minutes. At $9 billion, that is $510 million per mile and $900 million per minute saved. In the last video, we talked a lot about this Hartford, Connecticut linchpin concept. Let's revisit that with a couple more options. First, extension to Springfield, Massachusetts, and then Boston. I covered this some in my video about possibilities for New England HSR. Check that out if you haven't seen it. Coming out of Hartford to the north, the Hartford-Springfield line is 3 tracks, consolidating to 2 and then 1 in places. There is room for 2 tracks the whole way though. Grade separation is not necessary as we will be at or below 110 miles per hour in this version. Amtrak owns the route, so electrification isn't an issue. The route can support 90 miles per hour with a tilting train to where it crosses the Connecticut River north of the town of Windsor Locks. We'd like to replace that crossing with one running diagonally through Kings Island. The 2 bridges required for a new crossing would allow speeds to continue at 90 miles per hour. 5 miles south of Springfield, the route crosses over into Massachusetts, and there is a brief 110 mile per hour section on a 3-mile straight. Relatively slow through Springfield, which has room for 1 more track over a super old bridge into the station. The station currently has room for extra platforms. This would be 25 miles. I have it averaging 79 miles per hour and taking 19 minutes. I have cost at $3.3 billion. That is $132 million per mile. In the New England high-speed rail video, I had Springfield to Boston at 1 hour and 4 minutes, bypassing Worcester. That would give a New York City to Boston total of 3 hours and 26 minutes. Add 25 minutes to stop in Worcester, Massachusetts. Springfield to New York City would be 2 hours, 18 minutes. Next, Hartford, Connecticut to Providence, Rhode Island via the old New York and New England Railroad right-of-way, which is now a rails to trails trail. Out of Hartford to the north and then directly over the Connecticut River. I used this in the last video to get to Interstate 84. Once past Interstate 84, it is quite circuitous and winds its way to Windham, Connecticut. I'm going to give you a straightforward version and then we'll see if we can improve that. Windham has a population of 25,000, probably good enough for an NEC regional stop. The route then enters the narrow Shetucket River Valley and goes on an adventure. Generally, inland Connecticut is difficult, it's very hilly and uneven. After wandering 10 miles to the south, the route moves back north and finally east again around Plainfield. Up to this point, the route is largely around 60 miles per hour, even with a tilting train. However, coming into Providence, Rhode Island, the geometry gets better and there are a couple of short bursts as fast as 125 miles per hour. This would then hook up with the NEC main line 2 miles south of Providence Station. This is 89 miles. I have that taking 1 hour and 15 minutes for an average of 71 miles per hour. I have the cost on converting that to electrified rail at $6.7 billion. That's an average of $75 million per mile. If we put that into the mix of things we've talked about, we get 3 hours 50 minutes between New York City and Boston, which is about what it takes now. Now let's make a faster version. Starting in Manchester, New Hampshire, we'll dig a 5-mile tunnel to cut out some meander. There is going to be some smoothing with cuts, and sometimes that will occur through existing neighborhoods. There would be damage, but it wouldn't be heavy. On the east side of Windham, we'll bypass that big jog south and cut across mostly open ground for 11 miles, but about 4 miles would be in tunnel. Again, some structures would need to go, but it's not bad. Then over the Quinebaugh River on viaduct and reconnecting with the old route just east of Plainfield. Slow for a bit there, then getting to the faster part with some low-cost smoothing to retain speed. One last tunnel about 7 miles long between Warwick and the Flat River Reservoir, then existing right-of-way the rest of the way but grade separated. That would cut the route down to 75.5 miles. I have that taking 39 minutes for an average of 116 miles per hour. Cost on that is $15 billion. That is $200 million per mile and $230 million per minute. That would be 3 hours 15 minutes between Boston and New York City. Are either worth bothering with? Let me know. Another suggestion is the old Boston and New York airline route. Out of New Haven, Connecticut to the northeast at slow speed until north of Interstate 95. The route here is single-tracked and owned by Genesee and Wyoming. However, there is room for 3 tracks for most of its length. The route looks fast at first glance, but is punctuated frequently by slower speed curves. This will keep it mostly in the 60 to 90 mile per hour range. The route intercepts Middletown at its Connecticut River crossing 23 miles from New Haven. This is okay for a regional stop. Things continue within the status quo. Another 25 miles toward Boston, we meet up with Windham again. This and the New York and New England route briefly run parallel through the old town of Willimantic. The airline will then head off to the northeast, status quo for another 22 miles until reaching Putnam, Connecticut. From there, things free up a bit, and while not fast, it tends more toward the 90-mile-per-hour end of the status quo. Another 21 miles and we reach Woonsocket, which is another potential regional stop. Then it's northeast to Franklin, Massachusetts, which is Massachusetts Bay Transit Authority territory. Between Middletown and Franklin, this is currently rails to trails. The route is mostly 110 mile/hour capable between Franklin and Reedville, 17 miles northeast, where it hooks up with the NEC. This section is 140 miles. I have it taking 1 hour 52 minutes for an average of 75 miles per hour. I have cost on that at $9.8 billion or 70 million per mile. This would result in a Boston to New York City time of 3 hours and 27 minutes. That's 16 minutes saved, 610 million per minute. A glaring deficit is that this wouldn't stop anywhere of significance between Boston and New Haven. Because of that, I don't think it's worth showing how good you can get it, but I knocked off 24 minutes for an estimated 15.4 billion. That's in line with other options on time and cost that are able to stop at additional viable places between. Lastly, let's talk about the rejected New London bypass and connect it to the Long Island High-Speed Railroad for kicks. In Old Lyme, this would hook up with Interstate 95 and run along that right-of-way for a while. As stated before, Connecticut is hilly, so this will occasionally run in tunnel. 8 miles east of Old Lyme, the route would briefly follow Interstate 395 before hooking toward New London in a tunnel. It would emerge next to the freeway and then fly over the Thames River between the two existing Interstate 95 bridges. By the way, that is the NEC future idea. At Westerly, the route would transition to State Route 78 briefly and then cross into Rhode Island to meet back up briefly with the NEC. Here's where things get a little brutal and where the opposition came from. The route would then take out about a dozen homes, run through the middle of a nature preserve, and then take out another dozen homes before finally rejoining the NEC at Kenyon, on the southern end of one of the fastest parts of the NEC. I have this taking 22 minutes over 44.5 miles for an average of 121 miles per hour at a cost of 11.4 billion. That's a savings of 20 minutes over present at 255 million per mile and 570 million per minute. That would get Boston to New York City down to 3 hours and 23 minutes. Combine that with our Long Island High-Speed Railroad route and you have 2 hours, 8 minutes Boston to New York City with stops in Providence, Riverhead, Ronkonkoma, and Jamaica for 38.4 billion. That works out to 245 million per mile and 400 million per minute. It's interesting to consider how the NEC might be improved. There are nearly infinite ways, but we've covered a pretty good chunk in 2 videos now. Let me know what you thought about the options presented in this video. You should like them better, most of them were your ideas. Do you think we'll see Boston to DC on the NEC in less than 5 hours in our lifetimes? Let me know in the comments. Plenty more videos to come. I'm not quite sure what's next. Might be another Taking Back the Streets. I have also acquired a drone. I'm not quite ready to use it for channel content, but you might see that worked into the mix soon. And I'll be ready to update you regularly on Brightline West construction progress once they get going. But that's all for now. Until next time, I'll see you on that big beautiful freeway.